Okay, let us move ahead today in unit 2, understanding the concept of monoband, multispectral and hyperspectral remote sensing. We were talking about sensors, various types of sensors that are used. So we will understand what these sensors are all about. Okay, there are various types of sensors that are used. We will begin with understanding the multispectral sensor. So these are the instruments that are designed to collect in more spectral bands over a wide range of electromagnetic spectrum. Okay, so within these scanners or the sensors, we can sense very narrow bands. These are also known as scanners because they are scanning some area, the way we scan some images, some photographs, or some notebook copies, or some notes that you have jotted down in copies. Okay, so there are primarily two types of scanners. They are these sensors. They have mainly two types of scanners. They may be a cross track scanner and a long track scanner. Now this track is the track which is followed by the platform. Okay, if this platform is moving from here and going towards this side, then this is the track, the way a track of a runner is said to be, right? A runner runs on a track, a definite track. Likewise, this platform also covers a definite track. So these scanners, they may be a cross track scanners or a long track scanners. So as the name suggests, likewise the work they do is. So a cross track scanners, what do they do? If say this is the part of a scanner, this is the place where scanner is present, it may have a sensor, and this sensor will move like this, the way it is shown here in this image. Okay, like this, it is rotating. So it is covering this part, again this part, again this part, and again moving like this, the way a whisk broom works. Okay, while we are using a whisk broom, what do? We give a push here and then again bring the broom here, and then again give a push here, then again bring this broom here. In the same way, the scanner, what does it do? It starts scanning from this point, it keeps scanning, then again comes back, then again starts scanning, then again comes back, the way it is shown here. It scans here, again it will come back and then start scanning, then come back. Okay, so here is the oscillating mirror. These are the scanning mirror systems, scan back and forth along the flight line at right angles. Okay, this is very effectively shown in R.P. Gupta. You can see it from there also. While I'm going to discuss that the content in the book, I'll discuss it that time. So this is what a cross track scanner is like. It is also known as a whisk broom scanner, depending upon the way it works. Okay, so a cross track scanners are also known as whisk broom scanners. Other one is a long track scanner. Okay, the way it is shown here. How does this works? How does a wiper works? How does this broom works? Okay, so likewise, what is done? The scanner is here, the track is, say the track is from here to here, it will keep scanning while going along the track. So what is it doing? Going along the track, and it is keeping on scanning. So this is the way a push broom works. Okay, so a long track scanners are also known as push broom scanners. How are they different? They give a linear array of detector is used. Okay, and they don't have a rotating oscillating mirror the way it was here. Here there was a rotating mirror, but here they have linear array of detectors. These detectors are the CCDs, right? So the scanner here, it will have a linear detector array which detects each and every pixel on the ground, the ground pixels depending upon the IFOV. Okay, so each spectral band sensing requires its own linear array. So each spectral band will have a definite array, right? So they can record multispectral images very easily. So this is the major difference. Across-track scanners are like whisk broom scanners. They have scanning mirror system, okay, and the system scans back and forth along the flight line at right angles. Whereas the along track scanner, also known as the push broom scanner, it records multispectral image just beneath the aircraft, and it has a linear array of detectors. It doesn't have a oscillating mirror, okay. So if we see the variation between this, the main mirror scanning versus linear scanning, array means a sequence, okay. So a linear array system has several advantages. It acquires stronger signals, smaller, weightless, it uses less energy, it has higher reliability, and it has longer life expectancy. But it has a different disadvantage also. It needs to be calibrated all the time, okay, and it has limited range of spectral sensitivity. So here you are seeing how a across track multispectral scanner looks like. Across track multispectral scanner, okay. I'll again show you. A cross track multispectral scanner means the whisk broom one. Along track is the push broom one, okay. So this is the whisk broom scanner or the across track scanner. This is the device, and this is the material or the component, the unit which is used to change the signals or record the signals, the digital signal, which are further changed into analog afterwards, okay. So here you can see various images taken in different bands. So if you can combine all these together, we'll get a multispectral remote sensing system. So this is how across track imageries are obtained, and this is an example shown here. This is a along track multispectral scanner. These are usually used more, okay. So this is the along track multispectral scanner, the push broom type of the scanner, which will show the data which is being obtained here in the digital format. They also may have some indicators of analog here. So this is the unit which is connected to the scanner here. Here you can see the along track imagery, okay. All right, let us end this lecture now. What did we study today? We understood various types of scanners, the multispectral scanners, various types of multispectral scanners. They are of two types, across track and along track. Major two types, okay, across track and along track. The across track is also known as whisk broom, which has a lens in it, scanning mirror in it, whereas the along track has it works like a push broom. It has a linear array of detectors. There is a variation in the advantage and disadvantage. The advantages include acquiring stronger signals, having higher reliability, small, weightless, longer life expectancy, whereas disadvantage include calibration many a times, okay. Then we saw how a cross track scanner looks and how the images that it takes in multispectral sensor scanning system, and how a along track multispectral scanner looks and how the images are there, okay. All right, thank you for now. Please ask question wherever you're not understanding, and while making notes we will be using the book by R.P. Gupta. So this is a important part which comes in your exam also. In short answers you may be asked write a note on whisk broom or a cross track scanner, or write the difference between a cross track and a long track scanners, what is a push broom scanner, how does it works. Okay, so there are definite figures which have to be made, and likewise the definition that have to be made, we will discuss it from RP Gupta. Okay, please ask questions. I won't understand, I won't get to know if you're understanding or not if you don't ask. All right then, thank you for now.